Hi, I'd like to talk about the R210 Larkspur receiver. This was part of the Larkspur military communication equipment. It was first deployed in 1955. It's originally developed by AT&E, and I think later Plessey took over manufacture of it. This is a 1957 example. Still going strong. It was originally, it comes in a aluminium extruded cabinet, so it could be sort of dropped into water and not damage it. It replaced the wireless set 19 equipment that was used during World War II, and it was still in use up until 1975, so it had like a 20-year lifespan. It's quite a good receiver. One of its key points was that you could set the frequency accurately on this wonderful tuning strip dial here, which is effectively a piece of film that is being moved on rollers, and as you change the waveband, a white strip it highlights the particular band that you're tuned into. So it's quite a clever piece of design, really, to make something like that. The mechanism is quite incredibly complicated. It's full of gear wheels and goodness chains and goodness knows what else in here to allow you to adjust the tuning, and it uses a particular type of motion that makes the scale linear. Very, very nicely made radio. Certainly the construction quality, no expense spared. Has quite a lot of valves in it. Valves were already becoming obsolete during the 1950s because transistors were becoming the thing. Its replacement, the Klansman equipment, the whole radio took less power than this takes just to power up the heaters. The radio has various modes of operation. It has an AM mode, which obviously is great for broadcast stations, and of course a lot of the early equipment was AM, and it also has a BFO, beat frequency oscillator, and that means that you're able to tune into single sideband stations which sound like Donald Duck, but you switch in the BFO and it renders the single sideband stations instantly usable. You can also put a narrow filter in to deal with listening to Morse code stations. So you can switch in this narrow band mode, and then you can quite accurately tune into to Morse code. Now, I wanted to see what this was actually like on the air, so I've paired it up with a transmitter from the ARRL manual, the American Radio League manual. This is a 6L6 transmitter with a big crystal single valve transmitter, which is really quite fun. Obviously that would allow use in CW in Morse code to make contact with other stations. So just explain the actual setup we've got here. This radio was designed to run on, sorry, turn that down a bit. This radio was designed to run on 24 volts from a vehicle battery, and it has what they call a vibrator power supply, which is what this thing here is, and it's effectively like a buzzer, really, that turns the DC from the battery into AC to produce the 180 odd volts that the set runs on. I'm actually feeding it from a mains transformer, and this set would have originally been used with headphones. But I've got a little, I've put a loudspeaker on the output here to so that we can hear what's going on. This is just a high voltage power supply which is supplying power to this 6L6 valve transmitter. It's 300 odd volts that's being fed to that, and then because these transmitters, this one would be early 1950s, so very much the same sort of period. Because of the fact that the output from these is not very clean, modern transmitters are much cleaner than this. I've added in a bandpass filter for the 40 meter band that we're going to use this on. The only other thing I've had to do is obviously I need a way of switching between the transmitter and the receiver. So it's actually quite a complicated process to switch over. You turn the transmitter on, which provides power to the heaters are on all the time on this, but the high voltage is switched on and off with this switch. Then you have to switch the antenna, needs to be switched from the receiver onto the transmitter. But more than that, obviously the transmitter is putting out a considerable amount of power, and the receiver is looking for tiny amounts of power in the region of microvolts. So you need a way of really trying to isolate the receiver from the transmitted signal, which is why there's two switches on this box. One of them does the switching over, and the other one is an extra set of switching over to try and stop that completely overloading the receiver. Also, you would need to turn the volume down on the receiver, because it really does it really does make a racket when you get it tuned in. So by the time you can actually clearly hear a station, which is sort of here, you switch over and the noise is horrendous, so you need to also turn the volume down. So the switching over process is quite complicated, and then when you want to go back to receiving again, you have to switch the transmitter off, switch the antenna over, and turn the volume back up. So it is quite a difficult thing to use on the air. Okay, now just a further note. In order to change frequency on this, you have to unplug the crystals, which look like this. They're huge because they get quite warm when with the amount of power that the valve puts into them. So you have to switch this on. You have to switch. Hang on, let me turn this down. You have to switch this on and then adjust this to get the lowest current, which also that's also the point at which most of the power is going out from the valve. Otherwise, all the power is dissipated into the valve. The only other bit of equipment we've got here is, of course, the Morse key. And you can hear actually the crystal warming up as if you run it for any length of time. Anyway, we're going to have a go with it and see what happens.